So the next operation we're going to be doing with these rational expressions or with these fractions is division. So division is easy because we're actually going to turn it into a multiplication problem. So if you remember up at the top, the do now, if you remember, these are just regular dividing fractions. So you notice that we can have the division sign like this, or we can have the fraction bar, which also means division. So the three words we remember in order to do these correctly is keep, change, flip. So we keep the first fraction, we change to multiplication, and we flip the second fraction. So we're going to keep 2 over 4. We're going to change to multiplication, and then we're going to flip the second fraction. So flip it to 10 over 6. Okay, now that it's a multiplication problem, now we do it the exact same way we did last week. So we can multiply right across from here. And then we're going to simplify. So divide the top and bottom by 4 and get final answer 5 over 6. Okay, the next one we are same thing, dividing fractions, but this time we have variables with exponents. So we're still going to keep, change, flip. So we're going to keep the x over 7, or sorry, x to the 7th over x to the 9th. Keep that. Change to multiplication, and then flip this guy. Okay, now we multiply right across, and then we simplify. So multiply x to the 7th times x to the 7th. Remember, we add our exponents. So we get x to the 14th over, add the exponents on the bottom, x to the 13th. One last step is to simplify. So remember, when we have bases with fractions and we're dividing, we subtract our exponents. So 14 minus 13 is 1. So x to the first, and it's going to go on top because that's where there's more. So you can write x to the first. You can write it over 1 if you want, or you could just write x. They're all the same thing. Okay? So the last one is we're doing the same thing, but instead of the division sign, we have the fraction bar, which also means division. So we keep the first fraction, the 3 over 5. We're going to change from division to multiplication, and we flip the bottom. So be careful when you flip the bottom. Instead of 7 over 5, it becomes 5 over 7. Okay, multiply right across and get 15 over 35, which simplifies to 3 over 7. Okay? So we're going to do the same thing with these rational expressions, except we're going to have to do factoring. So if you notice, the first thing is the keep, change, flip, which we just did. And then once it becomes the multiplication problem, we're doing the same thing as last week. So factor everything and then simplify. So the first thing I'm going to do is I'm going to rewrite this so that I change this to multiplication and I flip the fraction. So while I'm doing it, why don't you try to do it also? Okay, now that I rewrote it so that it's a multiplication problem, now I'm going to factor everything. So I'm going to factor it. You try factoring on your own. Okay, Okay, so the first part I just took out the GCF. We couldn't do anything further. And the denominator I factored as well as the numerator. And the 3x, we can't do anything with that. So that just stays 3x. Okay, so now we are at the crossing off point. So if we see any factors that are the same, we can just cross them off. So we have the 3x and the 3x that cancels right out. We have the x plus 5 and the x plus 5, and that looks like it. So x plus 1 and x minus 1, remember they don't cancel because one's a plus, one's a minus. So gather everything, that's our multiplying part. We have the x plus 1 next to x minus 4 over x minus 1. And the x minus 1 in the bottom you can put in parentheses if you'd like, but you don't have to because it's the only factor. Okay, next one, same thing. Let's rewrite it so it's multiplication. Okay, so I kept the first fraction. I changed to multiplication, and then I flipped the second fraction. Okay, now we're going to factor everything. So again, the top, we can just do a GCF. The bottom is the difference of two squares. And then the second fraction, we actually can't do anything with that. And again, if you want to write the x plus 3 right here, if you want to write it in parentheses because you like the way it looks, go for it. Okay, now we're going to do the simplifying part. So we're going to cross out what matches. Okay, since that's it so far, if you can kind of see it, you can simplify it now. I'm talking about the 2x and the 2x squared. If you need to rewrite it, then rewrite it. So I'm going to rewrite it. So we have 2x squared, x plus 3 on top, over, 2x on top. 2x on top and x plus 3. On the bottom, we have a 2x squared and an x plus 5. Okay, so now it's a little bit easier to see now that it's written on top of each other. So the 2's cross right out. X over x squared. Remember, when we're dividing like bases, we subtract our exponents. If you want to write the exponent of 1 right here, you certainly can. So final answer, we have x to the first in the bottom, because that's where there's more. The x plus 3 is still on top, in parentheses or without. And then the x plus 5 is still on the bottom. Okay, now the next problem, if you remember from the multiplication, when we just have things multiplied together, remember that's a little bit different because we don't have to factor. So first I'm going to remember to keep, change, flip. Don't forget to do that when we have division. So keep the first fraction. Change to multiplication and flip the bottom. Flip the next fraction. Okay, now since this one we don't have to factor, this one we're going to multiply right away or gather everything on the top. So 8 times 7 is 56. X cubed times x to the 4th is x to the 7th. Remember, we add our exponents when we are multiplying. And then I'm going to put my exponent here, it's 1. And then we have y to the 4th on top. Then on the bottom, do the same thing. We're going to multiply or gather everything. So on the bottom, we have 8. Just the x. I'm going to write x to the first because I like to see my exponents there. And then we're going to have y cubed. Okay, that's what we have when we gather everything. Now we can simplify. So simplify 56 over 8 and get 7 or 7 over 1. Okay, x to the 7th over x to the 1st gives me x to the 6th on top. Y to the 4th over y cubed gives me y to the 1st on top. And we actually didn't end up needing over 1, but if you want to leave it, you can. Multiply and flip. Okay. Now that we know that there's no addition or subtraction, this is the one we're going to multiply straight across and gather everything. So we get 135 x to the 7th, y to the 3rd over 45 x to the 5th, y to the 5th. Okay, and then we can go ahead and we can simplify the numbers. So 135 over 45 gives me 3, or 3 over 1. X squared in the top, and then y squared in the bottom. And if you have a 1 in front of the y, that's fine too. Okay. Alright, last row. So keep, change, flip, keep the first fraction, change to multiplication, and flip the second. Okay, now we're going to multiply right across, and when we multiply, there's really nothing that happens except I'm going to write the number, the 10 out front, just because the number usually comes out front. I want everything to line up. But there's really nothing that combines. So it's just 10. You can write the letters in whatever order you want. I would just have them line up. So I'm going to write a first, a squared, x squared, y to the 4th, over 6. I'm going to write it in the same order, a squared, x to the 4th, y. Okay, just because we got a lot of letters, that's all right. Still doable. Okay, now we're going to reduce 10 over 6, so it reduces to 5 over 3. The a squareds cancel right out. I get x squared in the bottom and y to the 3rd in the top. Okay, now the next one, we're back to seeing addition and subtraction, so we know this is going to be a factoring one. So first I'm going to keep, change, flip. Okay, now I'm going to factor everything, so 7x, nothing happens with that. The bottom, all I can do is take out a GCF. The second fraction on top, factor that. And on the bottom, all I can do is a GCF. Okay, now we're going to cancel out. So the x minus 5 cancels out with the x minus 5. The x minus 6 cancels out. And if you see it right now, you can do it. If not, gather it and then cross out. The x's actually cancel out. So the only thing we have left on top is 7. The only thing we have left on the bottom is a 2. So 7 over 2 is our final answer. Okay, now number 7. So you're going to see a few of these come up on the homework. So make sure you remember, if you only see one thing, like see how this is 3x squared plus 5x, it's not a fraction. We're going to turn it into a fraction. So write it over 1, right? That's the same thing as writing it over 1. So on your homework, if you see any problems where it's not a fraction, turn it into a fraction by putting it over 1. Okay, same directions. Keep, change, flip. Keep the first fraction, and then flip the second one. So 1 over 3x squared plus 5x. Okay, now I would maybe suggest pausing the video to factor this, because remember, you're going to have to do multiply and add and then divide by the leading coefficient. So I'm just going to jump right to the final answer. We have 3x plus 5 and 2x minus 3. Okay, over 4x squared, nothing we can do with that, times 1 over, all I can do on the second thing is take out an x, and I have 3x plus 5 left. Okay, really not too much you can do here. You can cross out the 3x plus 5, but that's it. That's all we can do on this one. That's the only thing that cancels out. So if I gather or multiply right across, the only thing I have is a 2x minus 3 times 1, which is just 2x minus 3. You can put it in parentheses or not. Over, if I multiply 4x squared times x, I get 4x cubed. Final answer.